3 hours ago, you picked up the controller. Now you're putting it down, and something feels off. Not bad. Just off. Like you just stepped out of a pool and gravity is heavier than you remember. This is second one of coming back. And what's happening in your brain right now is stranger than you think. Let's start with what you just did. For 3 straight hours, your brain was receiving a constant stream of visual, auditory, and emotional information from a city that does not exist. Leonida isn't real. Vice City isn't real. Every neon sign, every alligator crossing the road, every stranger on the sidewalk was built by an artist on a payroll. And your brain processed almost all of it as if it were real. Here's the thing about your brain. It doesn't have a hard switch that says, this is fiction. It has a dimmer. And the more immersive the experience, the further that dimmer gets turned down. Psychologists call this transportation theory, first formally studied by Richard Gerrig in 1993, then expanded by Melanie Green and Timothy Brock in the early 2000s. When you're deeply absorbed in a narrative world, your brain doesn't fully separate it from lived experience. You get transported. The deeper the transportation, the harder the landing when it's over. And this is worth sitting with, because of the scale of what you are actually plugged into. Rockstar spent north of $1 billion building this world. Hundreds of artists, writers, and engineers spent years constructing Leonida down to the individual palm tree. The first reveal trailer broke YouTube's all-time record with over 90 million views in 24 hours. The second trailer pulled in nearly 500 million views across platforms in a single day, 6% of the entire global population watching one minivan chase in Miami that isn't Miami. This is arguably the most engineered piece of interactive fiction ever built for one purpose: to make your brain forget, as completely as possible, that none of it is real. It's working exactly as designed. Games transport you further than almost anything else humans have invented. Why? Because you're not watching a story happen. You're causing it. Every choice runs through your own hands. Your brain doesn't log that as watching. It logs that as doing. Now let's talk about the actual chemistry, because this part isn't theory. In 1998, a team led by neuroscientist Michael Kepp used PET scans to measure what happens inside the brain during gameplay. Published in Nature, the study found something concrete. Players' brains released measurable dopamine into the striatum, the same reward circuit implicated in food, sex, and drugs, while they played. And critically, the better a player performed, the more dopamine was released. Follow-up imaging work in the 2010s went further, finding that frequent players show structural changes in these same reward regions. Gray matter increases. Altered responsiveness in the ventral striatum. This isn't a metaphor about games being addictive. It's your brain's oldest reward system, the one that evolved to reinforce eating and reproducing, being repeatedly and deliberately activated by a fictional car chase. Now think about what doing actually meant to your nervous system for those 3 hours. You were making split-second decisions. Driving. Reacting. Sometimes escaping danger, sometimes causing it. Your heart rate was elevated. Cortisol and adrenaline were circulating. Your prefrontal cortex, the part of your brain responsible for planning and risk assessment, was working overtime, constantly predicting what happens next. Then you press pause. None of that machinery shuts off instantly. This is called the game transfer phenomenon, first documented by researcher Angelica Ortiz de Gortari in 2010. She studied hundreds of gamers and found something consistent across almost all of them. After extended sessions, players reported involuntary mental intrusions from the game world into real life. Seeing health bars over strangers' heads. Instinctively reaching to reload real objects. Scanning a room for exits the way their character would. One participant described glancing at a busy intersection and for half a second, mentally calculating it like a driving mission. This isn't a glitch. It's your brain doing exactly what it's built to do. Pattern recognition and behavioral rehearsal don't come with a reality filter attached. Rehearse something intensely enough, and your brain treats it as relevant experience, whether or not it happened in a body. So what does that mean for the version of you sitting on the couch right now? For the first few minutes after you stop, you are, neurologically speaking, still partially somewhere else. Studies on cognitive washout time, the gap between stopping an absorbing task and full mental disengagement from it, suggest this transition isn't instant. It can take anywhere from several minutes to over an hour for arousal levels, attention, and mood to fully reset to baseline. This is why the real world can feel strangely slow right after. Muted. Almost dull. You just spent 3 hours in an environment engineered by a team the size of a mid-sized company, drawing on decades of dopamine research, to maximize stimulation every single second. Real life was not built by a design team. Real life has no mission markers. No immediate feedback. No dopamine hit for opening the fridge. There's a term for this in behavioral psychology: hedonic contrast. Your brain doesn't evaluate pleasure in isolation. It evaluates it relative to what you just experienced. After 3 hours of constant novelty, danger, and achievement, an ordinary evening looks flatter than it actually is. Not because your life got worse. Because your baseline for comparison got hijacked. Now here's where it gets more interesting. Your sense of self was involved too, not just your senses. When you're playing a game with an embodied character, something researchers call the Proteus effect kicks in. Coined by Yee and Gerrig Bailenson in 2007, it describes how people's behavior and self-perception shift to match the identity of their avatar, sometimes for hours after they stop playing. For 3 hours you weren't just controlling Jason or Lucia. Some part of you borrowed their nerve, their speed, their consequence-free confidence. Putting the controller down means handing it back. That's part of the off feeling too. For 3 hours, you were, in a very real cognitive sense, someone else. Faster. Freer. Someone who could just restart if things went wrong. And now you're back to being you. Slower. More permanent. No respawn button. Let's talk about time, because your sense of it was also being quietly rewritten. Immersive activities compress subjective time. This is well documented in flow state research, going back to psychologist Mihai Csikszentmihalyi's work in the 1970s. When your attention is fully absorbed by a task with clear goals and immediate feedback, exactly what a 100-plus-hour open world provides constantly, your brain stops checking the clock. 3 hours can genuinely feel like 40 minutes. Which means the shock isn't just emotional. It's temporal. You look up and the light outside has changed. Meals got skipped. Messages went unanswered. There's a small disorienting gap between how much time you feel like you spent and how much time actually passed. Zoom out and the pattern gets bigger. This franchise has been running this exact experiment for over a decade. The last mainline entry sold roughly 190 million copies and kept millions of people logging in daily for more than 10 straight years, an almost unheard-of lifespan for a single piece of software. That's not luck. That's 10 years of data on exactly which chemical levers to pull, and when, refined into the version you were just playing. What you're feeling right now on the couch isn't an accident or a personal weakness. It's the product working correctly, past the point where the controller left your hands. So if you feel a little strange right now, a little hollow, a little like you need a minute before you can talk to another human being normally, that's not weakness. It's your nervous system recalibrating from a state of engineer hyperstimulation back to the much slower rhythm of unscripted reality. There's a version of this worth paying attention to though. Researchers studying problematic gaming patterns note that the discomfort of this comedown is exactly what pulls some people back in faster than they intend. The dip in mood after stopping creates a pull to relieve it the fastest way available, which is usually picking the controller back up. Understanding that this feeling is temporary, chemical, and completely normal is often enough to let it pass instead of chasing it away. Give it 20 minutes. Walk outside if you can. Eat something. Talk to someone in person if there's someone around. Your cortisol will settle. Your dopamine baseline will reset. The world will stop feeling like it's running at the wrong frame rate. And somewhere in the back of your mind, for the rest of the night, some small part of you will still be half listening for a mission alert that's never going to come. That's not a malfunction. That's just what happens when a species built for slow, physical, consequence-heavy reality spends 3 hours living inside a billion-dollar simulation, refined over a decade of data, engineered to feel more alive than life actually is.